For this problem, it is asking us to solve for the length of AB, so side AB. Now, what we could do is just use the Pythagorean theorem if we had all the sides, but we don't. And so since we don't have BC, we can't use the Pythagorean theorem. But what we can do is we can recognize that we can use the Pythagorean theorem to solve for DB. And when we do that, we're going to have enough information to use the between triangle ratios that we learned this year. So let's go ahead, since these two are similar, let's go ahead and first solve for BD. So how we're going to do that is going to take a squared plus b squared equals c squared. So we'll just say 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. 9 plus 16 is 25. And we know the square root of 25 is 5. So that missing side that I labeled x, I'm going to actually relabel that and label it as 5. So now that I have that triangle, I have enough information to use the between triangle ratios to go ahead and solve. So if you notice, the 4 and the 10 are in corresponding positions, so I can place them as a ratio 4 over 10. And again, since they're similar triangles, we can go ahead and compare the hypotenuses, 5 and an unknown. So we're going to put the small side over the large side. So we have 5. And we're going to put it over x. Now, if you remember, we are going to cross multiply. So we're going to get 4x equals 50. Now we're going to simply divide both sides by 4, and we get x equals 12.5. So what is the length of AB? The length of AB equals 12.5. So again, a couple of things that we did here. We used the Pythagorean theorem, and then we used the between triangles ratio to solve.